Hi everyone, this is Mr. Lucas. We're covering Chapter 3 this week for Net 126, which covers VLANs. All right, so I put some VLAN notes and VTP, and I'll talk about what both of those are. I put those notes on Moodle under the Chapter 3 section under the chapter Learning Materials. So I'm just going to kind of explain them today, give you a rough outline of what Chapter 3 is all about. So the first thing we have is this diagram up here. So it's pretty important to note, and you can reference this even later as we're continuing to cover stuff. We've got different kind of colors here. So you see the green PC1 to PC4 here. Is in a VLAN 10, which is a virtual local area network. So what that does is it kind of segregates the traffic to where only those two PCs can talk to each other. PC2 and PC5, same thing. PC3 and PC6, the exact same thing. And we'll kind of talk about what the purpose is for even wanting to do something like that. And then kind of what the logistics are about how we configure it. So, and your packet tracer assignments, of course, will reinforce that. So what are VLANs? Well, they're virtual local area network protocol. It provides segmentation and organizational flexibility. It provides a way to group devices within a local area network without them needing to be physically next to each other. So they can be on two totally different networks, two sides of a campus, two sides of the world even, and you can provide a way to group the devices within a LAN if you configure it correctly, and they can only communicate with other end devices in the same VLAN. They are based on logical connections, not physical connections, so it does not matter what port you plug it into. It all matters how you configure it logically. The benefits are improved security because, again, up here in our example, PC3 and PC6 are the only ones that can talk to each other. Reduced cost. An early implementation of this was you would have to like rewire everything to have the PCs or the end devices plugged into the right ports. Here, it doesn't really matter where you plug them in or where the location is geographically, as long as you configure it correctly again. Better performance. When you send out a broadcast packet, let's say PC1 was trying to figure out where everybody is. PC1 will often send out like a broadcast, which is like a hello everybody on the whole entire network to the switch so it can figure out where its neighbors are. Well, that broadcast, if we did not have VLAN set up, that PC1 broadcast would get sent to PC2, PC3, switch 1, switch 3, would then send it out to PC4, PC5, PC6, and then return it. So it's just like flooding your network with all these packets. Well, in this case, because we have VLAN set up, if PC1 sends out a broadcast, it only goes to other switches. So PC1 would send it out to S2, but instead of it going to PC2 and PC3, it's only going to go to switch 1, then it's going to go over to switch 3, and then it's going to go out to PC4. So it really cuts down on the unnecessary traffic on your network, okay? Smaller broadcast frames, like domains, like we were just saying, which again helps your performance. IT efficiency, kind of again piggybacking off of that, and management efficiency in terms of how we manage and look at our different devices and how they're connected. Types of VLANs, we got a data VLAN. It's used to carry user-generated traffic. It's more common practice to separate voice and management traffic. We all probably have some type of voice over IP phone, maybe at work or even at home. I know I have it at home and at work. And it basically sends those voice packets like you're on the phone over the internet, all right? And it still suffers from the same things. It could have drop packets or, stuff like that, but it's gotten a lot better as download speeds have gotten a lot better. We've got default VLANs. The default ones are set up. You'll notice there's a VLAN 1, and there's a couple in the thousands for like token ring and some other stuff that we usually don't use in today's advanced technology. We've got a native VLAN, which actually operates from trunk ports. And again, those trunking, as you can see here, are the switch to switch connections. Okay, so S2 to S1, S1 to S3. Those need to be configured in trunking. Okay, the end devices from like a switch to a PC need to be in access mode. So trunk mode from switch to switch, access mode from switch to PC. Okay. And again, that native VLAN we'll configure later. Management VLAN, usually you can piggyback those off of the same VLAN, management and native. All right, and then of course, if you had a voice one, you could separate that out. Normal VLAN ranges are 1 to 1005. 1002 through 1005 are already reserved for, as we said, token ring, automatically created, can't be removed. Those are already there when you do a show VLAN brief later. All your VLAN configurations are stored within a database called a VLAN.dat, short for database. If you were to wipe that out, that would clear out all of your VLAN configurations. And of course, you do have extended VLAN ranges that range from 1006 all the way up to 4094. So each VLAN is assigned a number, okay? Now, up here, if we wanted our VLANs to work, we would have to go through each switch 2, and say VLAN 10, and then we could name it faculty. VLAN 20, then name it student. VLAN 30, then name it guest. So we got to create it each time on each switch. So I have to repeat that on switch 1 and repeat that on switch 3. Well, there is a technology called VTP, Virtual Trunking Protocol, that will actually share those VLANs, so you could create it on like one switch and then share that throughout all the other ones. And it really depends on which mode they are in. We do not cover configuring that, but I thought I would put it in your notes because it is a neat protocol where you only got to configure your VLANs once and then it'll share it depending on what mode it's in. So usually the server mode is the one that's like doing all the sharing. You create the VLANs there. The client mode, you can't actually create any VLANs, but it just receives the updates from your other ones. And then transparent mode, they aren't actually participating in all of it. It just, basically forwards it on, but it ignores updating its own database. And when you're doing VTP, you must have a domain and password, kind of like a username and password, to make sure it all shares correctly. But we actually don't cover configuring that in any labs in this chapter anymore. So how do we create a VLAN? Well, again, as I mentioned, when you're in configuration mode, you do VLAN ID. So it'd be like VLAN 10 or VLAN 20. So it needs a number there in substitution of VLAN ID. And then you notice it'll do config-VLAN. So then we're going to do VLAN and a name. So it's looking for like students, faculty and staff, management, so that you can look at it later and see, oh, that's what that VLAN is used for, okay? VLANs can be created several at a time, separated by commas or ranges. To delete one, you basically just type in no VLAN 20 or no VLAN 30. Okay, and if you want to delete the entire database, you do delete /VLAN.dat. That will clear everything out. Okay. Assigning a switch port access to end devices, again, as we said before, if you had like switch 2 was connected to PC1 up here. So we go into interface FA011 and configure it to only carry VLAN 10 traffic. We configure FA018 to only carry VLAN 20 traffic, FA06 to only carry VLAN 30 traffic. So down here, to put it in access mode, again, we would do like interface FA011, switch port mode access, switch port access VLAN 10, okay? So we can do that. If we want to configure it between switches, so here we've got FA01 and FA01, FA03 to FA03 between the switches. So down here we would do interface, sorry about that, interface G01, switch port mode trunk, switch port trunk native VLAN that must match on each end, as well as the trunking mode. So on each end, this one will be management, I think they did native VLAN 99. Okay, and then switch port trunk allowed VLANs. Here you need to carry all the traffic, okay? Because if you look up here, okay, PC1 may send something to PC4. Well, it's got to go through S2, S1, and S3. So in between the switches here, we need to be able to carry all VLAN traffic, 10, 20, 30, and 99, okay? So you need to make sure you allow all of that VLAN traffic using these commands here, okay? So it says include all VLAN ID numbers, including the native VLAN in your allow VLAN command. The native VLAN ID must match between both ends of a trunk link. So make sure you configure that correctly. And we'll practice all this stuff out in a little bit. And then they show you the VTP configuration, but we're actually not going to do any labs on those. They've omitted that out of the routing and switching curriculum, okay? So again, it's all about VLANs and network segmentation. So I've got a little PDF document just to show you some examples. So here it says drag the Ethernet frames to their destination PCs for this scenario. Not all envelopes will be used in every scenario. Scenario 1, PC1 sends a broadcast frame, so remember that means sends it out to everybody, so PC1 sends it out. They're in VLAN 10, okay? So which PCs will receive a copy of that? Well, based off of what we were talking about, only, and I'm going to highlight it here, only PC4 would receive that internet frame or that packet, okay? So only PC4 will receive it. And so it's coming from here, from PC1, okay? And it's going to end up at PC4. These other PCs will not get it because they're not in the other, in the same VLAN. So it's going to travel here, 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 and out to PC4, okay? Now, let's look at our second one. It says part 2, scenario 2. PC2 this time sends out a broadcast. They've kind of switched it up on us a little bit. Now PC2 is in VLAN 30, PC3, PC4, and PC6. So we're going to send it from PC2, okay? So where is it going to go? Well, it's going to go to our switch, and then it's going to go out to PC3 here. So PC3 is going to get it. It's also going to broadcast out to our other switches, and now PC4 is going to get it. Okay, and then it's going to go down to PC6, and PC6 is going to get it. All because they're in VLAN 30. And these switches are going to get it because they should be in trunking mode carrying all VLANs. So PC1 and PC5 will not get the broadcast. Lastly, one more example. It says PC3 this time. Again, they switched it up. All right, we're in VLAN 10 here for PC3. So it's going to send out a broadcast frame. All right, it's going to send it across the switches, and it's only going to send it to PC5 here. Okay, it's going to get the actual broadcast. Nobody else is going to get it because nobody else is in VLAN 10. Okay. So that's just kind of a review of how VLANs operate and segregate your network. Again, go through these notes. Our packet tracer assignments are going to reinforce that and kind of how all the connectivity works, because again, switch to switch needs to be trunking. Switch to the end device, those ports need to be in access mode, but carrying the correct VLANs are also important. And we'll go through some show commands. Show run will show you a lot about what each port is configured with, port by port, and then show VLAN brief will also show you a lot of information about which ports are assigned to which VLANs. So either one of those are good show commands for this chapter. So again, now you're ready to get started or read through the curriculum if you haven't yet. Do your Cisco exam for chapter 3, and then of course try out your lab assignments. There are help videos for the first 3 lab assignments, configuring VLANs, configuring trunks, and troubleshooting a VLAN implementation scenario 1. And then of course you'll have to do the use those skills that those help videos cover, and then do your skills integration challenge on your own. If you have any questions, make sure you email me, call me, stop by my office. Thanks for tuning in to our chapter 3 notes.